All right, we're going to get into carbon dioxide and gasoline and electricity and how we can tell how much we are emitting into the air. So first we're just going to look at this little graph about carbon dioxide emissions from 1750-ish to 2012. So first, some fossil fuels. Just, what are some fossil fuels? We could talk about oil, gas, natural gas, coal. I'm sure there are others, but just kind of some basic things. Observations. Well, I think it's pretty clear that there was a huge increase starting in about 1950, which, that's kind of when cars started to become popular. So we definitely use gasoline and oil a lot with the cars. So number 3, estimate the global emissions for 2012. Well, 2012 is here at the top. So if you take that all the way over, I'm going to say it's about 9,500, that's a bad color, now 9,500 million tons of carbon. And 9,500 million is the same as 9.5 billion tons. So depending on how you want to say that. That's a lot of carbon dioxide emissions, right? So just a lot. So let's get into some math. Now, some decent information here. 1 gallon of gas weighs about 6.2 pounds, which is weird. I don't feel like it's that, well, I guess I never really carry it, but it doesn't feel that heavy. A gallon of gas is about 87% carbon and 13% hydrogen by weight. So how many pounds of carbon are contained in a gallon of gas? Well, 87% of the 6.2 pounds is carbon. Remember that of means multiply. So 0.87 times 6.2 tells us that 5.394 pounds of carbon are in the gallon of gas. Now in number 2 it says estimate how many kilograms of carbon are released. Well, we know that if we have 5.394 pounds, well, 1 pound is 0.4536 kilograms. So that makes your pounds go away, and this is roughly 2.45 kilograms. So just kind of refreshing our conversions a little bit. Number 3, now let's estimate how many pounds of hydrogen are contained in a gallon of gas. Now there's 2 ways to do it. You could do 13% of 6.2. So 0.13 times 6.2, same way we did the carbon, and get an answer of 0.806 pounds. And that would be perfectly fine. Or you could have said, well, there's 6.2 pounds total, and we know that 5.394 pounds is carbon, and therefore we have 0.806 pounds. Either way, mathematically, you get the same answer. So this is kind of the setup to all of our carbon emissions problems. Okay, so we have a water molecule. It's an atomic weight of 18. Therefore, to calculate the amount of H2O produced from a gallon of gas, the weight of hydrogen is multiplied by 18 divided by 2, or 9, because it's H2O. There are 2 hydrogens, which is why we have to divide by 2. Okay, so estimate how much water in pounds a gallon of gas produces when burned. So we're saying hydrogen times 9. Well, hydrogen times 9, hydrogen is 0.806, multiply that by 9, and you get 7.254 pounds of water. So when you burn a gallon of gas, you create 7.254 pounds of water. And I'm thinking, okay, where does that go? Right? It's emitted into the air as fumes, it drips from your exhaust, I don't know, but it's just weird to think how this all works. Now, carbon combines with oxygen to form CO2, which is carbon dioxide. This increases the weight of the carbon by a factor of 3.67. By a factor means multiply. So how many pounds of carbon dioxide does a gallon of gas produce? Well, we would take the carbon times 3.67. So we know the carbon is 5.394, multiply that by 3.67, and 19.8 pounds of carbon dioxide per 1 gallon of gas. And this is our big conversion with gasoline. So if you know how many gallons of gas you produced, you can find out how many pounds of CO2 you are producing or emitting into the atmosphere. So burning 1 gallon of gas produces 19.8 pounds of CO2. Again, our ratio will be 19.8 pounds to 1 gallon. And this is only for gasoline. Gasoline. So let's do a couple problems with this. If you use 30 gallons of gas a week to get to school, how much CO2 is emitted by your commute? Now, if you see gas CO2, you know your very last identity ratio should be 19.8 pounds over 1 gallon. Always, because how much CO2, we're talking about pounds, and it's your 19.8 pounds per 1 gallon. That will allow you to work backwards. So I need to get rid of this gallons. Well, in this case, I have 30 gallons a week, so 30 gallons over 1. My gallons cancel out. I multiply in the numerator, and I end up with 594 pounds of CO2. So if you use 30 gallons of gas a week, you're putting 594 pounds of CO2 into the atmosphere. Number 7, if the tank of a car holds 40 liters of gasoline, how many pounds of CO2 are produced by burning the entire tank? Okay, so once again, gas, CO2, we know we're going to use 19.8 pounds per 1 gallon. But the problem is, we start with liters. So I need to change liters to gallons. Well, liters is metric, gallons is customary. I have to jump across the pond. So hopefully you remember that 0.9464 liters, that allows us to cancel out our liters, is 1 quart. Okay, so that gets me out of liters. And I know that 4 quarts is 1 gallon. So now my quarts cancel out, and now I have gallons. Gallons, I'm left with just pounds. So the numbers in the top I multiply, I divide by the 2 numbers in the denominator, and I end up with 209.21 pounds. So 40 liters of gas produces 209.21 pounds of CO2. If a car gets 26 miles to the gallon on average, how much CO2 is emitted into the atmosphere when that car travels 100 miles? Again, we're talking about cars, gas, CO2. So my last one is going to be 19.8 pounds to 1 gallon of gas. Because I know now working backwards, I've got to put gallons here. Well, I have 100 miles, and I have 26 miles to the gallon. So 1 gallon would give me 26 miles, right? That's using this ratio here. That makes my gallons go away. But now I have to get rid of these miles because I want just pounds at the end. So 100 miles, and that allows my miles to go away. And now I'm left with just pounds, so I can find my how much CO2. So 100 divided by 26 times 19.8 leaves me with 76.15 pounds of CO2. If a car gets 30 miles per gallon on average, how much CO2 is emitted per mile? Now, this one's a little bit different because it says CO2 per mile. So our final answer should be in pounds over miles. So when I'm doing this, I still am going to have to use the 19.8 pounds over 1 gallon, but now I have to somehow get rid of the gallon in the bottom and get miles down there. Well, when I look at this, I've got to get rid of gallons. Okay, well, I have 30 miles per gallon. So per gallon is where the division bar. So bar, 1 gallon, that means 30 miles is going to go on the bottom. Well, when my gallons go away, look at my labels. Pounds on the top, miles on the bottom. That's exactly what I want. So I'm going to take my 19.8 on top divided by 30 and get 0.66 pounds per mile. And that is carbon dioxide with gasoline.